Dear students, welcome to my second lecture. I am Rokhshana Parvin, lecturer, Department of Civil Engineering, World University of Bangladesh. This lecture content will cover properties of soil. For example, water content, density of soil, bulk density, dry density, density of solids, saturated density, submerged density, unit weight of soil, bulk unit weight, dry unit weight of solids, saturated unit weight, submerged unit weight, specific gravity of soil, void ratio of soil, porosity of soil, degree of saturation, percentage air voids, air content and relative index of soil. Properties of soil. Water content. The water content W, also called the moisture content, is defined as the ratio of weight of water WW to the weight of solids WD in a given mass of soil. So we can say water content W equal to weight of water WW divided by weight of solids WD into 100. The water content is generally expressed as percentage. Density of soil. The density of soil is defined as the mass of soil per unit volume. Bulk density. The bulk density or moist density is the total mass of the soil per unit of its total volume. So we can say bulk density of soil ρ equal to total mass of the soil m divided by total volume V. It is expressed in terms of gram per centimeter cube and kg per meter cube. Dry density. The dry density is the mass of solids per unit of total volume of the soil mass. So we can say dry density ρd equal to mass of solids md divided by total volume V. Density of solids. The density of soil solids is the mass of soil solids per unit of volume of solids. So we can say density of solids ρs equal to mass of solids md divided by volume of solids Vs. Saturated density ρsat. When the soil mass is saturated, its bulk density is called saturated density. Thus, saturated density is the ratio of the total soil mass of saturated sample to its total volume. Submerged density ρ'. The submerged density is the submerged mass of soil solids per unit of total volume of the soil mass. Unit weight of soil gamma. The unit weight of a soil mass is defined as its weight per unit volume. Bulk unit weight. The bulk weight or moist weight is the total weight of a soil mass per unit of its total volume. So we can say bulk unit weight of soil gamma equal to total weight of the soil W divided by total volume V. Dry unit weight of soil gamma D. The dry unit weight is the weight of solids per unit of its total volume of the soil mass. So we can say dry unit weight of soil gamma D equal to dry weight of solids WD divided by total volume V. Unit weight of solids gamma S. The unit weight of soil solids is the weight of soil solids per unit volume of solids. So we can say unit weight of solids gamma S equal to weight of solids WD divided by volume of solids Vs. Saturated unit weight gamma sat. When the soil mass is saturated, its bulk unit weight is called the saturated unit weight. Thus, saturated unit weight is the ratio of the total weight of a saturated soil sample to its total volume. Submerged unit weight, gamma prime. The submerged unit weight is the submerged weight of soil solids per unit of total volume of the soil mass. So we can say submerged unit weight gamma prime equal to submerged weight of soil solids WD sub divided total volume of soil mass V. The submerged unit weight is also expressed as gamma prime equal to gamma sat minus gamma W, where gamma sat equal to saturated unit weight of soil and gamma W equal to unit weight of water. The unit weight of water is 1 gram per centimeter cube, 62.4 pound per feet cube and 9.81 kilonewton per meter cube. Specific gravity G. Specific gravity G is defined as the ratio of the weight of a given volume of soil solids at a given temperature to the weight of an equal volume of distilled water at that temperature, both weights being taken in air. In other words, it is the ratio of the unit weight of soil solids to that of water. So we can say specific gravity G equal to unit weight of soil solids gamma S divided by unit weight of water gamma W. Void ratio. Void ratio E of a given soil sample is the ratio of the volume of voids to the volume of soil solids in the given soil mass. So we can say void ratio E equal to volume of voids VV divided by volume of soil solids Vs. Porosity. The porosity N of a given soil mass is the ratio of volume of voids to the total volume of the given soil mass. So we can say porosity N equal to volume of voids VV divided by total volume V. Relation between void ratio and porosity. Figure 2 shows the soil element in terms of void ratio E. If the volume of voids is taken equal to E, the volume of solids by definition would be equal to 1 and the total volume equal to 1 plus E. Similarly, from figure 1, if the volume of the voids is taken equal to N, the total volume of the element will be 1 and hence the volume of solids would be equal to 1 minus N. From figure 2, we have by definition of porosity N equal to volume of voids VV divided by total volume V equal to E divided 1 plus E. Similarly, from figure 1, we get by definition of void ratio E equal to volume of voids VV divided by volume of solids Vs equal to N divided 1 minus N. Degree of saturation SR. In a given volume of voids of a sample, some space is occupied by water and the rest by air. In a fully saturated sample, the voids get completely filled with water. The degree of saturation SR is defined as the ratio of the volume of water present in a given soil mass to the total volume of voids in it. So we can say degree of saturation SR equal to volume of water VW divided by volume of voids VV. The degree of saturation is usually expressed as a percentage and is also known as percent saturation. For a fully saturated sample, volume of water VW equal to volume of voids VV, and hence degree of saturation SR equal to 1. For a perfectly dry sample, volume of water equal to 0, and hence degree of saturation equal to 0. Percentage air voids Na. Percentage air voids Na is defined as the ratio of the volume of air voids to the total volume of the soil mass and is expressed as percentage. So we can say percentage air voids Na equal to volume of air voids Va divided by total volume V into 100. Air content AC. The air content AC is defined as the ratio of volume of air voids to the volume of voids. So we can say air content AC equal to volume of air voids Va divided by volume of voids VV. As we know, volume of air voids Va equal to volume of voids VV minus volume of water VW, and degree of saturation SR equal to volume of water VW divided by volume of voids VV. Finally, we can write air content AC equal to 1 minus SR. Relative index ID. The term density index ID or relative density or degree of density is used to express the relative compactness of a natural soil deposit. The density index is defined as the ratio of the difference between the Boyer's ratio of the soil in its loosest state Emax and its natural Boyer's ratio E to the difference between the Boyer's ratios in the loosest and densest states. Relative index ID equal to Emax minus E divided by Emax minus Emin, where Emax equal to void ratio in the loosest state, Emin equal to void ratio in the densest state, E equal to natural void ratio. When the natural state of the questionless soil is in its loosest form, then natural void ratio E equal to void ratio in the loosest state Emax, and hence relative index ID equal to 0. When the natural state deposit is in its densest state, then E equal to E min, and hence ID equal to 1. For any intermediate state, the density index varies between 0 to 1. From figure, we can see if the density is high, then void ratio will be minimum and density will be maximum. Similarly, if the density is low, then void ratio will be maximum and density will be minimum. And this is the end of our today's lecture. Thank you everyone.